to the day 5 of this MLDL summer school. So for today we have a very special person who has worked enormously in the field of AI. So he is none other than Mr. Prashant Saikia, an AI engineer. He is associated with Aulgas Cyber and Beam Plus Lab, Hong Kong. He holds an MSc and MPhil degree from Hong Kong University of Science and Technology. His expertise is from language models for NLP, AI, and finance, various domains. I welcome Prashant Saikia, Mr. Prashant Saikia, please talk, and I hand over the platform to him. Thank you.
Thanks, Devajit. So good morning, ladies and gentlemen, distinguished guests and fellow enthusiasts. Welcome to today's presentation, where we are going to embark on an exciting journey into the realm of building talking avatars and chatbots. This field of talking avatars and chatbots, I think, holds immense potential to transform the way we interact with technology and also with each other, because all these metaverse companies that are coming about, the whole idea is that, like, how do you make interactivity in a remote manner more engaging? That's the whole idea, right? So with that motivation, I started on this journey like about 4 or 5 months ago. So I think the applications of this technology can be in different fields, like let's say assisting the users in customer support, right? Like, instead of having a person do it, if we are able to embed the knowledge base inside an avatar or a chatbot that is virtual, right? I mean, that I think can hold immense potential. So yeah, I mean, I think these intelligent agents will become an integral part of our digital landscape soon. So yeah, my goal today is to share with you about my journey into learning how to build these conversational chatbots, and also to explore the possibilities of this field. So as a practitioner coming from the industry, my focus today is not going to be on the theoretical foundations of how these things are built, but rather on how to build these things in the first place. So from the application perspective. And because there are several moving parts to these things, as you will soon see. So the goal is to show you how to combine these several things into a coherent whole, right? So, and of course, as you will also see, and I'm hoping that I'll be able to impress upon you, that much of this is dependent on our creativity, basically. Because I think with rapid automation that is already happening around the world, right? I think we will soon find ourselves in a world where all these tools are democratized, and you don't really need to know how to run Python programs or do anything technical. Basically, the layman, the TikToker, the YouTubers, all these people, I think if you have a genuine interest in these things, you can learn how to just use those tools. Probably they will become like a drag and drop kind of thing, right? And I think that's why the democratization is coming soon anyway. So the goal is not to impress upon you too much on the theoretical foundations of the deep learning aspects of how these things are working underneath, but just to rather show you how to build these applications. So yeah, with that introduction out of the way, let's get going. So I think my talk is going to be divided into 2 parts. In the first part, I'll talk about building 2D avatars, and then in the second part, it will be more about building 3D avatars, which is more involved, right? But I think 2D avatars is very exciting because already this should be able to get us like 80% of the way in terms of understanding how the flow works of these things. So essentially, the way I did it, right, is that I start with 2D images. So I create an avatar. Let's say we have Keanu Reeves here, right? I can make an avatar of Keanu Reeves using Midjourney. I hope many of you here, since you're enthusiasts about this field, maybe you will have heard about Midjourney, Stable Diffusion, all of these new tools. So Midjourney is, I think, the best in terms of the quality that it produces is totally like it blows away everything else out of the water. So we first start with 2D images. We make them avatars. Then in the second part, what we do is we can change the clothes. Like you can see this avatar here is wearing this hat and black jacket, right? But here I've changed the clothes. So this particular thing, I think I found Stable Diffusion is a good way to do this, and because you can control the different aspects of the avatar. So you can you can change the color of the hair, clothes, whatever, this kind of stuff, right? And I'll show you a tool that I've built for this also. Then obviously comes the conversational part of the avatar, which is to make it speak. And obviously we have a lot of free open source text to speech tools. I'm using Google TTS because it's free and good enough for the POCs. But of course, like if you want very good quality of like speech, then you can go for these professional tools like Speechello, Coca2. I think these are not prohibitively expensive, but also like not super cheap as well, like 60 or 70 US dollars per month, something like that. So yeah, I mean, they produce good results, but I think for our purposes, Google TTS is good enough. Then once the speech is created, this is how the flow works, that we have to fit the speech into the avatar, right? So basically lip syncing. And how do you make it realistic? For that, we use another deep learning model called Wave to Lip. There are others, but I think this one performs good enough. And I think, if I'm not wrong, this Wave to Lip model was built by some folks in IIT Kharagpur back in 2021, if I'm not wrong. So anyway, I think this model performs really good. And by the way, I have shared the Google Colab notebooks if anyone wants to try. I'll go through them anyway, but you can try it as well. Then at the end, if the video after the lip sync, whatever is produced, if that video you find that it's not producing very smooth video, then there's another model called thin plate spline model. So this model I don't always use. It's just that like whenever I feel like the video is very glitchy or like jumpy, then I use this, right? Um,
Sir,
let's
these notebooks are not available to us, Colab notebooks.
Why?
Is it shared via mail, or I
No,
can see that?
I've not shared by mail right now, but I'll be sharing the slides later on.
Okay, later on. Okay,
Yeah, so once I share the slides, then maybe you can try this out.
okay, sir. Okay.
So let's go through one demo, right? I have it here. So I'm using Google Colab Pro here. As you can see, that I'm using the V100 GPU. The only thing it does is it makes it run faster, but even the free version, right, has a Tesla T4 GPU, so that one also is not slow. It's more faster than like a NVIDIA 3080 Ti, right? So I mean, until about a week ago, I was using the T4 myself, but just last week my company gave me access to Colab Pro, so I'm using Colab Pro for this demo. So anyway, let's get cracking with the demo, right? By the way, I'm hoping that all of you know how to use Colab notebooks. In case you don't know, I'm just going to go through this briefly in the meantime that it gets initialized. So you select a runtime here, change the runtime type. By default, it is without GPU. It'll be CPU initially, none basically, none. But you change it to GPU, then select T4. That is free, given by Colab. And I think you can run a program for up to 8 hours or something, if I'm not wrong. But yeah, I mean, more than 10 minutes, if you pause or don't do anything, inactive basically, more than 10 minutes, then it pauses and you can run it again by connecting the runtime. You can see the RAM, GPU, RAM, whatever. In the free version, you will find I think 12 GB or 16 GB RAM, something like that. And hard disk will be like 80 GB or something, which is big enough for anything, right? Anyway, I think this is initialized now. Let's get cracking. So this is the text that I'm going to make the avatar speak, right? Just writing some random text, whatever. So the next step is to get the length of the audio, because this length is going to play an important role in this step. So what we are basically doing is we are taking the image. So here I will upload an image of the thing that I want to make an avatar. So for that, I prepared some demo images. So let's say I take this, right? This is an avatar I made based on the picture of my wife. And let's make this as an avatar which speaks, right? So basically the flow will be like this, that this image that I've uploaded there, and there's this audio that was generated, right? So this audio has some length. This length is 24.528 seconds. In first, what I'll do is I'll just convert this audio into a video with this image that I uploaded. I think this name is,
Static image, sir. At that point, it will be a static image with just audio. Sorry,
yes.
static video. Okay. Okay, sir.
At this point, it is just a static image with an audio. So this
Okay.
is the image. This is the static image, right? At this point, this is just going to be, yeah. At this point, it is just going to be a image with a a
Audio.
video with a length of
Okay.
24.5 seconds, right? So once that is done, then we will use the lip syncing and make it a speaking avatar. That is the intermediate step that is needed here. This step is the intermediate step that is needed to create this. So once that output video is created, so I'm creating this file called input video. This will go as an input to the wave to lip model. That's why I'm calling it an input video. So this I'm going to pass on to the wave to lip model to make the avatar speak. So let's install wave to lip here. So if you want to see the code, it's here. This is the GitHub from where I'm downloading and installing the requirements for this library.
So is this same concept as currently? Sometime back, it was famous in news. Deep fake videos. Is that same concept?
Yeah, concept is the same, but the implementation is different. The ones that come in the news, they are generally built by professional softwares. Like
Okay.
the deepfakes have been going on for more than 2 years now. So the ones that I'm showing you now is from open source community, or like things that were published maybe a year or two ago, which in terms of the rapidly moving tech world is like dinosaur age, right? 2 years ago is
Mhm.
a long time
Yes.
ago. So right now what they're showing you in deepfake, you will probably not even be able to say that this is fake,
Yes,
right?
sir. Yes, sir. Yes.
Yeah. So this is not that level, but this is just showing you one of the good implementations I found. So this wave to lip produces some realistic lip syncing actually. So yeah, I mean, we have these things, right? So I'll upload these two models. You can also upload these. Um, so there is a folder here. So this is the input image and the input video. So these two files are needed. These two are the same files here. I'm actually uploading because I have a better quality of like here I'm producing the audio in 30 frames per sorry, in what is it called, like the audio hertz, the frequency. That frequency is a bit more audible here. That's why I'm uploading from local. But anyway, you can use these two files. These are the two exact same files that I'm using. Okay, once this upload is done, after that we will run this. I'm hoping this works. Sometimes in demos, anything can go wrong. I'm hoping that doesn't happen today. So this step will take some time because it is using generative adversarial network in the backend, basically. And this is where the powerful GPU that I'm using will come into the play here. You can see the GPU usage will start going up. So
So
in
this
my
thing
machine,
works with human images, or like a monkey or a cat or dog image will be also turned in avatar and they will also lip sync, or just human images.
so this particular model, wave to lip, this was trained on human images because the idea was to create speech for humans. But
Okay.
then I've also experimented with dogs and cats, and it produces fair enough. Like it will not be as good of a lip sync as with humans, but it does produce some kind of lip sync.
Like
You
that,
can,
you remember there is a app Tom. There is a app that cat that speaks. It's in a
Yeah, Talking Tom. Yes,
Talking Tom. Yeah.
yeah. So yeah, I mean the idea is similar, but this particular model that I'm using, I mean there are several models for lip syncing, right? So this particular model that I'm using, Wave to Lip, this is trained on human images, so that's why it produces better quality lip syncing on human images, uh, and it does produce some kind of lip sync for animals also, but it's not going to be as high quality as with humans. And you can use other lip syncing models. Actually, there are others you can use which are trained on, like it can, you can even give an image of a car and the car will speak, that kind of thing, right?
Basically, there is no animation involved. It's just the model will turn the image into a video.
That itself is the animation, right? Like when something becomes a video, that is animation, right?
Okay, but we are not doing it like some with like not generating frames and making it. That model is doing that.
Yeah, the model is doing. So you can see there are 613 frames in this video that it is processing
Okay.
and then syncing it, right? So this step, by the way, is happening fast. That's what I wanted to say, because of the powerful GPU that I'm using. If you're using a T4 Tesla GPU, right, it will not be as fast. Maybe instead of taking 2 minutes, it will take you 10 minutes. That's the only difference.
Okay, sir.
Our video will be stored somewhere here in results. Let's play the generated video. So I don't know if the sound will come, but I'm hoping you can see the result.
Hello, I'm Alex, an AI avatar-based chatbot here to assist you.
Can you hear the sound?
Yes, sir.
You can hear the sound, right?
Yes, sir.
Okay, cool.
As a virtual entity, I exist to provide you with intelligent and personalized support across a wide range of topics. My purpose is to engage in meaningful conversation.
So yeah, that's basically the lip syncing output, right? That's what I wanted to show you. The rest of the notebook has other stuff also. You can do, you can try it out. So here is another thing that I wanted to show. Like if let's say the avatar image that we are using, right? Let's say we are not, I mean, we want to, let's say, make more changes on that thing, right? This is what I was talking about. So this is my GitHub. There's a project that I uploaded there called Virtual Clothes Try On. So you can basically try on different clothes. That's the idea. So I'm going to show that to you as well. So the way it works is that basically so it's working with Stable Diffusion in the backend. Stable Diffusion, you can check it out in Hugging Face. Hugging Face is one of the very popular, how do you say, like platform, not a library, but it's like a platform where you can upload spaces and your own models and stuff. So Stability AI is the name of the company which released Stable Diffusion, I think a year and a half ago. And Stable Diffusion is, I think, works well enough. Like you can generate images also, but I think Midjourney produces better images than Stable Diffusion. But for tuning the images to your own like custom requirements, for that purpose, Stable Diffusion is good, I think. So inside, so this is the repo that I downloaded just now. So here there's an app.py file. Let's run it, and it will launch like a front end, a UI that I built, where you can play with the images. And then it's downloading the main model actually, which is kind of 3.4 gigs. So it's taking some time to download. So by the way, let me, in the meantime, describe what these steps are also saying. So if, so this clip that I showed above, right? Say you are going to make a video which has multiple clips, not only this one clip, because this is just one clip, right? Generally videos will have multiple different clips. So if you want to make multiple clips, this is what this is for. Like if you repeating each of the steps 1 to 4, so that is what this is saying. And then if you have multiple clips like that, then you can combine the all those clips using this FFmpeg. Otherwise, you can do it yourself also. Like there are video editing tools like Final Cut Pro or whatever. Like I forgot the other one. But yeah, there are video editing tools where you can combine. Otherwise, I find that programmatically, FFmpeg also does a good job of combining. The only thing you need to do is you need to make a video list.txt file where you are listing the names of all of those individual videos, and it will combine everything for you. So anyway, I think this is finished running. So here is the UI. So let's say I want to, not this, let's use another image. Let's say I want to take my image, right? And then let's say, so this is how it works. We are going to select the main image which we want to change, and also we need to select one image where we are using this as a base to customize our main image, right? Then we also need to tell Stable Diffusion what we need to change. So this orange shirt, where do we want to impose? We are going to impose it on the t-shirt, right? We write t-shirt here, and then we start painting, and it will produce an output where it will do some interpretation of how this particular shirt should replace the t-shirt here. And this is a like a this is a, how to say, this is not a constant process. Like if you do the same thing again, the output will be different. So it's not static. You can make it static by using a different seed. Then every time you select the same input, it will give a different, the same output. But I think it's more fun to just try it out. Like this particular iteration is different than the previous one, right? So so let's say we have the shirt. Then we download this. Let's say we like this image. If we don't like it, we can keep trying it again. So let's say we like this image, and then we can use the same image for further customization. Now let's say we want instead of white shoes, we want a yellow shoe, right? We write shoe here and paint. So Stable Diffusion is unable to understand which part of the, like what this word exactly means, like with shirt, pant, shoe, hair, whatever you write, it understands. So let's say you like this, then you can save it by downloading here. Or if you don't like it, then try it again, because this is a non-static process. Every time you keep trying with the same input, it will give you different outputs. These are hyperparameters, by the way, guidance, scale, and steps. Steps is basically for the training, for the inference purpose rather. So if you give it more, it will take more time, but it will produce more like high fidelity outputs. I think 50 is a good middle ground to go with, something like that. So yeah, you can see that it has produced a different output. If you like it, you download it. If you don't like it, then try again, like that. So let's try another image, just for the sake of showing. Let's try Keanu again. And let's say we want to use this kind of a image for the shirt, right? Or the jacket, maybe. We can write jacket, whatever. So this is why I was saying that the creativity is very important here. Like you can see that this is giving us some inspiration for those, how do you say, like fashion designers, maybe. Like they can get some inspiration from what they want here. So yeah, this is just what I wanted to show. You can play around with this. I've shared the GitHub anyway, so you can build it. So yeah, let's move on to the other stuff. So this is the 2D image gathering. I mean the avatar creation process. And by the way, another thing I wanted to show you guys is Midjourney. So how I create in Midjourney. I mean, you can see YouTube tutorials, but I just wanted to just briefly touch upon like how to create images. If anybody of you has
Sir,
used,
one
yeah,
question. These are the machine learning techniques we used for.
yeah, these are the machine learning techniques
Sir,
used.
if we use these techniques, then how
Uh,
can I
I'm
start
not able to
like
hear you
a
properly. Can you bring
project
your
to make
speaker
it
closer?
so that I will be very
Can you bring your speaker
yes,
closer? I'm
yes.
not able to hear.
It's not. Hi, hello. It's audible.
Yeah,
Hello.
audible now. Yeah,
Yes, I'm asking that I want to build some projects on machine learning. So
yeah.
how could I start like that to build some machine learning projects and all that, so that I can put in my research area, because
Yeah,
now
so
nowadays
this
I'm
is
seeing this.
so this
Yes.
particular thing that I showed you, this is a machine learning project only, no? So let's go to my GitHub. So here I've uploaded. That's the same link that I'm.
Sir, you will send all the links in the our Gmail, that Google Drive.
Yes.
Not that. Yes, you have sent.
Sorry.
You have sent this
No, I've not sent now. I've
your
not sent
GitHub
yet.
ID.
I've not sent yet.
Yes,
But
if
I'll
you will
send it. Yeah.
update it so that we can go through your GitHub. Yes.
Yeah, exactly.
Okay,
So
thank you.
I'll share the slides with Debojit, and then he can share it with you guys.
So that we get updated like that, because if we are seeing that, then we also used to get forget it and all
Got it. Okay.
like
Yeah. So that's why I
and
put the links
if
here.
any
My
problem
intention
will
is to
occur,
share
then we
only.
can mail you directly, so that
Yes, and that's why
yes,
I've given
thank you.
my LinkedIn also here, so you can reach out to me here in LinkedIn.
Okay.
So yeah, I'll be sharing all of this. Don't worry. Um, so I mean, you can see the uh, so this virtual clothes try on, right? It's here. So you can try it out. Basically, I've given the instructions also properly how to use it. So anyway,
Excuse me, sir.
yeah.
Can I use these GitHub codes in my research area, and will that come in flag or not? Will that be counted as flag?
Counted as what?
Plagiarism? I mean, will it be a
Plagiarism.
plagiarized? Yeah.
No, it will not be plagiarism because I think no, I've not made a license here. But yeah, basically, since I'm uploading in GitHub, it's assumed that this is open source.
Okay. I mean, we can use it without. I mean, just mentioning your name, we can use your GitHub codes.
Yeah, you can use my GitHub post, and also basically the thing is like when you're writing a research paper, then instead of let's say citing a GitHub repo, you will cite the paper, right? So the paper whose technique I'm implementing here, that paper is open source anyway. So you're going to cite that paper, right?
Okay. Thank you, sir.
Yeah. Otherwise, you are free to use my codes. That's not an issue. I mean, if I'm uploading something in GitHub, means I'm expecting people to use it, right? The things that are like, I mean, I'm not willing to share. I'm not. I'm not going to upload in GitHub only.
Can you, I mean, like at the end of this session, can you please direct us how to use GitHub? Because sometimes it happens that we are using GitHub, we wanted to use the code, but we are not able to fetch the code out of it. So, I mean, I really don't know how to use GitHub properly.
Right. So basically, you can see some tutorials, but also just to briefly touch upon. So if you click on this here code, right, you'll find this link here. So this is the Git link. So all you need to do is open a terminal or command prompt, right? And then you have to have the Git installer installed. So you do Git, then clone, and then you paste the link, and then it will download there. Basically, that's all you need to do. If you're doing it by code, otherwise, if you don't want to do it by code, then you can just do a download zip. It will download the whole project, and then you can go inside the project and then run the command using these steps. Just do a cd, then pip install, and then python appy. Right.
Thank you so much, sir.
All right, no problem. So where was I? I was
Mid journey.
just wanted to show you how Midjourney works. So basically, you give a prompt here with this particular kind of a, I don't know what it's called. It's not a hashtag exactly, but it's like a command here, like
It
slash
is same.
imagine.
It is same like Delhi, na sir?
It is similar to DALL-E, yes, but the founders or the makers of Midjourney decided to like launch this product inside Discord server. So you have to install Discord, then go to Midjourney, and then sign up, and
And
then
it is
it's
fully paid. No, trials are
yeah.
not even available.
Yeah, so before it was used to be having a free version, but then so many people started using it that the server was crashing. So they just removed the free version. Now it's like $10 per month, 10 USD per month or something. I'm paying that because I mean this is not paid by my company. This is just me personally paying for it because I find experimenting with it to be like really like a nice hobby kind of thing. And there are things that you can learn about, like how prompting is done. Like some people give very long prompts, so here you can see that they're giving a longish prompt here, right? This is not a super short prompt. So if the more specific you are, like the more specifically you tell Midjourney what exactly you want to create, it will create that. So let's say, I mean, I'm giving you some example, right? So you can do hyper realistic whatever, whom shall we make? Hyper realistic piano in a forest with snowy mountain in the background. Whatever, we can basically up to your creativity and imagination. So the previous avatar that I was showing, I was saying that this is based on the image of my wife. So you basically upload an image of your like the base image whose avatar you want to create. You upload the base image somewhere, and then you take the link and then ask it to imagine this link in the shape of a Pixar character or Disney character, whatever, something like that. So it's creating here slowly, step by step.
Have you uploaded the photo of the actor, or it knows from its learning?
This is the prompt I gave. I did not upload any link
Okay.
here. This guy, it knows because it's a public figure.
Okay. Okay.
But yeah, I mean, so this is how you generate, right? And one more thing I wanted to show you, so U1, U2 is like upscaling. So this is image 1, image 2, image 3, image 4. Say you like image 3, right? So you just go on U3. That means it'll upscale the image 3. Upscale means like just make it bigger. Instead of like if you click it here, you cannot separate the image, right? Suppose you want only this image, then what you need to do is just upscale it like this, and then you can it'll open in the browser. You can zoom in. So you can see I asked it to make a hyper realistic image, so it made the hyper realistic image. If you ask it to make a cartoon, it'll make a cartoon like that. And this V1, V2 is basically versions. So let's say I like image 3, but let's say this whatever, there's this mark here. Suppose you want to change this, like you can't specifically change the mark per se, but then you can make variations. So V means variation. So if you ask it to make a variation of this third image, you select V3 and it will make the variations. So that is how it works. If you're happy with the variations, then you can upscale that particular variation and then save it. If you're not still happy, you can continue doing the variations. So this is how it works. I just wanted to show you that quickly. And if you go to the website midjourney.com/app, it will also store everything that you've done before, all your jobs. So I've till date apparently done 190 jobs. So yeah, I mean, these are the things that I've created. So you can also see the prompt that I've used here. So for this particular image, right, this is the prompt I used: beautiful mountain landscape with the silhouette of a man looking forward into the distance, like that. So whatever you want, you can create. So for this particular one, I wanted abstract lines and shapes, like that. For this one, I wanted a 2D sketch of a village with some volcano eruption in the background. So because I asked it to make a 2D sketch, it's making a 2D sketch. If I ask it to make a realistic image, it'll make a realistic image. So these are the ones I was telling about, like where I'm using a base image. So here I'm giving a image of my wife and then asking it to make a Pixar character in the style of Mirabel from Encanto. Encanto was a movie that came last year. So I wanted Midjourney to make. So I went through several variations. I like this one, so I use this one to show you guys in the demo. So yeah, that's how it basically works. This is me. I'm using my base image and asking it to make something. So anyway, that's it for the 2D part, right? Let's quickly move on to the 3D part. We don't have much time left. So 3D is not open source because 3D is using mostly, I don't know if you guys know, but 3D modeling softwares, which are like Unity, Blender, Unreal Engine. So these are generally used for making games. But yeah, I mean, I just wanted to see how we can use, because 2D is fine and all, but what if we want to create some like more interactive things, right? So the first one that I tried out is OpenCV, and it has a Unity plugin. Unity with an OpenCV plugin. So OpenCV is the default computer vision software that we all know about, right? So what it basically is doing is just to touch on the theory part a little bit. There is a thing called pose estimation. I don't know how many of you guys know, but I have worked on pose estimation before. It's there in my GitHub also, by the way, and one project. So basically, what it is doing is, if you give it a like a reference photo or video, it will try to compare your body movements. So that's what it is doing. So how it is doing is, it is going to track your key points. So there are like 22 or 25 key points in your body that it is tracking. The AI is tracking through the webcam, right? So one key point can be on your neck, another on your like the two shoulders, another on your hip joints, like that. Like those are called key points. So using those key points, it is comparing the moves, the body movements that you do. So that is the main idea here. You can actually go inside here and then see how I'm doing it. So that the idea is that instead of taking a reference image, how about we just superimpose our movements onto a 3D avatar thingy. So instead of like showing you running OpenCV and showing, it's much easier to just go to this link. I've prepared some demos already and recorded them. So this is how it works. So my face movements is being superimposed on this avatar here. So wherever I move, it'll move. If I open my mouth, it'll open its mouth. If I wink my eyes, it'll wink its eyes. It's just tracking your body movements, right? So this is a basic form of avatar creation. So here, as you can see, you can't do much customization in the sense that we want to create these avatars so that we are making it more engaging and professional. But then the person who is controlling it, like me, I'm not a professional actor, right? So I cannot like create a very good movement for the video. So basically, you are going to have to hire an actor for this, who is going to sit in the back end and do all this stuff. So this is basically what movies also do. But yeah, I mean, movies hire actors, right? That's the whole point. That if you, as a normal, like technical guy, want to create something like this,
Excuse me,
you don't know
sir.
yeah.
Sir, the movement of your face you have shown right now, sir, how you collect the data for that? That how the smile has been taken place, how you have moved your head, how to collect that data to impose in a machine learning project so that we can be done to our face also.
Yeah, so that process is all here in my GitHub, in this project. Where is it? Yeah, so here this create moves function is there. No, here you can see the details how it is creating. So it is taking each
Sir,
frame by frame.
sir, I
Yeah.
have seen in the Kaggle app something like that. There is always predefined data is there to something like that. The predefined data so that you can download it and through that you can take as a path so that that data can be imposed in some project and the result will be taken off. But how to collect that data in a newly formed to
Yeah, so for,
for a
for this
particular.
particular project, you don't need to collect data. What it is doing is this model that I'm using, this model itself, this pose module, right? This pose module, this pose detector has its capability to detect the key points. So the landmarks that you're mentioning, basically, you don't have to download this explicitly. It is already there and the model is trained. So you don't have to download the training data set yourself. It's all done in this function here. All you need to do is just basically use this class, this function. And the way also I'm showing you how. So this is the benchmark video here, and you can, yeah, basically just you can go through the code. Basically, it'll take me a long time to explain, and we don't have much time. So I just for now I'll just move on. to the next one. So OpenCV plus Unity, like I mentioned, is a good way to start with. But since we are not actors, we don't know how to do the poses very well. That's why we should try something else, I thought. So next I tried Unreal Engine. So Unreal Engine, if you guys know, it looks like this. So it's a gaming engine basically. You can design a game. So this is the open arena. Here you can import some 3D model or make some model. You can design models actually. But I'm not a designer. So what I did was, instead of creating my own model, I found there's this something called iPhone Live Link. Basically, you connect your iPhone. Excuse me, somebody's speaker is on probably. I'm hearing some background noise. Just playing here. Anyway, all right. So what I did was, let me just show you the demo here. So what it is. So actually, what is happening in the backend is I'm connecting my iPhone and making an IP connection to the laptop basically. So using this IP connection, uh, it is tracking my face movements here. So the same pose module that I was showing in OpenCV, that same thing in a more advanced version called the face mesh. So this face mesh is superimposed on the this is called the meta human avatar. This looks more high fidelity, right? That's why I'm using Unreal Engine here. So the idea is that the face movement should again be like superimposed here. But the way it is done, instead of tracking through the webcam, is through this iPhone Live Link, so that the person who is controlling it can do it wirelessly and also like sitting a bit far away. So that is the back end what is happening, and in the front end what is happening is this. Like, this is what you can export as a WebGL file, and then you can display it in your browser. So basically, this text-to-speech thing is going on here. So this is the text that I'm giving. It is, I mean, basically, I'm reading it out right now. But later on, my idea is like, instead of me reading it out, how about just use Google Text-to-Speech or something, or some professional software, so that it seems like the avatar is speaking and it'll seem more professional. So this is where the creativity again comes into place. Like if you can imagine a way where instead of using even text to speech, you can use GPT-3, right? You can connect GPT-3 to this somehow as a backend. Then you can have a conversational agent where you can go back and forth and have some proper conversation with them. So yeah, I mean that's where your creativity comes in. So this is the second 3D example. Then the other example I wanted to show is something called iClone. This particular thing is again not these are all not paid, these are all not free softwares. So here is iClone. You can see that my trial is over. So basically I got to play with it for 1 month, and my company is not sponsoring for this one. So I just made some demos in that 1 month. So this is how iClone works. So basically if you can see here, so basically you can transfer the movements from your, I mean, it's the same idea. Like you can transfer the movements into the avatar. So the way it is doing it is different. Just that's it. So you can see here that I'm giving it more high fidelity movements. Like it kind of feels like it's becoming a bit more real, right? Compared to the previous example where I'm using iClone to control. This is controlling the movements through predefined movements. So just like if a normal person would be standing, they would not be standing statically, right? They will have some hand movements, they'll be walking around, rotating, whatever. So this is a bit more advanced version of that same idea. So this is talking when walking, like that, right? So we can make this using iClone. You can install it, and then you will get a 1 month free version, free trial period rather. Then you'll have to buy this, I mean, if you continue using. It's not super expensive also. Like it's not a monthly subscription plan. It's like $600 but one time paid only. So if a company is really interested in doing something like this, they can pay that. Like $600 is not much for a company. But yeah, I mean, for me, I was just experimenting. So yeah. What else did I want to show? So iPhone live link is there, iClone is here. Okay, then another thing I wanted to show was, instead of mapping that iClone movement into that robot kind of avatar, how would I just map the iClone movements into the Unreal Engine plus MetaHuman thing that I was showing before? So for that, the demo is this one. So all of these things, by the way, they don't have codes, you can see, because this is just a design software, right? Animation software. So here, this is what I want to show, that we have this link, right? So from this is iClone's UI. So from iClone, I'm again creating a live link, but instead of this time, instead of through iPhone live link, I'm creating a live link into Unreal Engine. Unfortunately, I can't show you how this works because, like I said, the trial period is over, and that's why it won't work. Otherwise, actually, I learned all these things through watching YouTube only. You can also do the same. But basically, you have to create an IP connection, IPv4 connection between iClone and Unreal Engine, and then you can listen in on that IP and port. And once you do that, the connection will happen. So basically, the movements that were being done by this avatar, instead of showing on this avatar, I'm showing on the MetaHuman avatar from Unreal Engine. So this is the MetaHuman avatar that I created here, and then superimposing the movements from iClone onto this. I can actually show you the Unreal part, because Unreal Engine is it's not a paid software per se. Like all the plugins that are used in Unreal Engine, those are paid, but the software itself, Unreal Engine, is not paid, so it's free. Or the only thing you need is a laptop with a GPU, because otherwise, without GPU, this won't run properly. So that's pretty much it for 3D. Then I have some more stuff in appendix. Since we have a few more minutes, I would just like to go through them quickly. So I was just exploring other ways of creating all these things, right? So I found another way. Instead of using, like, a Unreal Engine can be super daunting for a beginner, right? Because we are not animators or designers. So there's a like a steep learning curve for all of that. Instead of that, I was looking for some simpler tools. So I found some. There's one called Ready Player Me. So Ready Player Me, if you go to the website, it's basically okay, here. So Ready Player Me, I created this 3D avatar in Ready Player Me. It's like drag and drop. You can't do much customization, of course, because it is drag and drop. But yeah, I mean, you can create some basic avatars like this. And so this particular avatar's demo, I can show you here. So here I'm again giving instead of giving a text to speech kind of audio, I'm just downloading some audio file from the internet and showing. It's the same idea, right? It's just the audio file at the end of the day, and then superimposing the audio on the avatar, making the avatar's lip movements sync with the audio, and then the hand movements are coming from the 3D software itself, which is smart. And like it's yeah, I mean, the designers basically try to create this only, that how do you make the hand movements and stuff like that such that it appears real. But this is a free software which is doing it for you. So yeah, that is Ready Player Me. Then oh yeah, by the way, so this Ready Player Me thing that I showed, the hand movements and all, they are coming from this website called Deep Motion. This is again not a free software per se. It has a trial period of 1 or 2 months, I forgot, but during that time I created that demo. There's another website called Monster Mash. This is a super interesting one. You can play around with this actually. So here you just draw something, right? Draw whatever, draw some shape, and then you do inflate. It'll make it a 3D object, and you can play around with it. You can do animate. For animation, you give some key points here, and then you can, like this point I have put as a key point, so it'll pivot around these 2 points now. So I can move it around like this. So just starting from a 2D image, I'm doing this. So you can imagine that you can make some human shape and it'll do the same, right? So you can play around with this. I didn't use it much, but because obviously I can't draw properly. But yeah, I mean, this is super interesting to explore. If that is the whole point of today's presentation, right? I'm just showing you different possibilities and you can explore. So okay, there are some more deep learning models, by the way, for generating 3D models of things. Like you take an image and you make a 3D image out of that. Like through 2D to 3D, how do you do that? So there is one thing called PIFU. I don't know if we'll have enough time, but yeah, there's a collab notebook shared by the authors. I can demo it to you, but I guess it's better that if you run it yourself. It's pretty easy to run. I mean, the instructions are pretty clear in this notebook. So this PIFU is, I found that it's pretty much used very widely in the 3D modeling community. So the idea basically is that instead of using proper softwares like Unreal Engine, where animators and 3D modelers can design the models, which is a very time-consuming task. So can we replace that whole tedious process using just a deep learning model? That was the whole idea. Of course, this doesn't perform to that level as done by the animators, but this is getting quite close. Like it will slowly, I think within the 5 to 6 years, probably it will become indistinguishable whether the 3D model that you are using is built by a deep learning model or is it made by a real human animator, right? It's getting close. So PIFU is a good algorithm that I found. You can try out the collab later. There's another thing called NERF. This is neural radiance fields. The idea is that it will generate the radiance field basically. So radiance field is like you take the image and then from there you are extrapolating everything around its surrounding, including the 3D of the body itself, right? So you can try this out. For PIFU, I think I had prepared the doc here. So just to show, like we have 2 minutes left. So just to show what PIFU does. Not this one. Oh yeah, this one. So you're just giving an image of the person's front, right? And it is able to recreate the back also without any other information. So that is the power of PIFU actually. I have given this collab. So this is an image. I'm just giving it, right? And the model is able to make it a 3D, but not only on the front, but also on the back. That is the whole point that I was trying to make, that these models are getting quite close. So now once you have this model object, you can just download the model object and then use it in other 3D animation software like Blender or Unreal or whatever. So yeah, that's all I wanted to share today. Hope you guys got some value out of it. And yeah, that's it. Thank you.
Thank you, Prashant, for your interesting demonstration. Any queries?
Yep.
So if not, then I would say that you have become graphic designer, animator, a painter, whatnot for your experimentation. So people can explore all these stuffs. I will share the your PPT, the Z drive.
Yeah.
So thank you very much, Prashant, for your interesting talk, interesting demonstration.
Yeah.
Yeah, we'll meet soon. Yeah.
So yeah, basically, guys, that was me, Prashant Saikia. Debojit will obviously share the slides with you, where you can find all the links. But also, in case you want to contact me, you can contact me in LinkedIn. My name is Prashant Saikia. I showed you my GitHub also. You can contact me there as well. Prashant Saikia, same everywhere. So that's it. Have a good day.
Yeah. Thank you.
Thank you.